Conference will now be recorded.
Okay. So now we are going to be discussing about the demo part of this particular PD perspective. Okay, so in this we are going to be looking all what all tasks we are going to be performing in technical as well as non-technical side. So technical stuff I'm going to be covering all of that. Any admin related queries which we will be having it in the second half. Okay, during the last 15 minutes or something, we will be discussing about all that particular admin related queries. Okay, so till that particular time, please don't ask me any kind of admin questions. Okay, that is the only request. And if I'm going very fast or any confusions, you can be able to stop it and ask me anytime. Okay, please be comfortable in that because as you are going to be joining it, you have to know each and every part. So that's why please be attentive and also ask queries on that. So as much as possible, technical side, I'll cover everything. Okay, right. So first, let's say very much from the basic, what is IC? That is full form. What is IC? Okay. What components? So basically, when we are talking about this particular ICs, based on the count of that particular transistors, which we are doping in a single area, we call it as LSI, MSI. What else we have? LSI, VLSI, ULSI. So like that, we have multiple transistors available in our particular, sorry, multiple IC variations we have available in our particular IC. Okay, so now guys, am I audible? Just a second. I'm audible, right? Hello. No.
Yes, you are.
Okay. Okay. Thank you. So now the last question which I was asking is how many transistors we have in that particular VLSI? How many transistors? Let's say when we are talking about SSI, we have is like 0 to 100. So when we are talking about MSI, 100 to 1000, LSI, 1000 to 10,000. So similarly, VLSI is from 10,000 to 10,000 to 1 lakh. Okay, so ULSI will be going like 1 lakh to 1 million. So similarly, we have GLSI. So that's how there are multiple terms coming in that particular section itself. Okay, so now whatever we have known only majorly when we talk about our industry, we say first is like semiconductor industry, or else we will say is like VLSI. But the transistors level we are going to be using is greater than millions, or we can say greater than billions also we have it. But we have stick to that particular term VLSI only. Okay, just for easier terminology or anything, based on our particular whatever Purana is coming, that we will follow, right? So that's why I say the same we will be having for our particular part also. Okay, so first is like IC. So first is IC. So as you said, that is an integrated circuit, and in this particular integrated circuit, we will be having SSI, MSI, LSI, VLSI, ULSI, GLSI, like that multiple. Okay. So now, based on that particular transistors present in that particular circuit, we will be having all these particular terms. Now, the next part we are going to be having over here is like, or let's say we will be discussing in the basics part is like, in how we are going to be manufacturing that IC. Whatever you have done in that particular engineering, right? Steps of manufacturing. So when you go as a fresher level, you should know that particular steps. What are second order effects? How it is impacting my working? So all that particular basics are required when you go as a fresher. Or let's say when you go for any kind of manufacturing based companies, right? So during that particular time, they will ask this particular questions about the transistor level, the second order effects, the manufacturing structuralization, everything they will try to touch it. So that's why in your basics, we have two sections again, analog designs and digital design. So in analog designs, we will be covering about that particular manufacturing process. Okay, and also second order effects will be covered. And now when it is coming to digital design, you will be seeing that particular conversions, K maps and all that we have, right? That K maps you will be able to solve it few problems. And also digital code conversions, binary format conversions we have, right? So that conversions, addition, multiplication, all that kind of like basic. And the next one more is like using mux development using AND gates, different ways of structurizations. The reason why we want that is like, let's say we don't want very much depth in that particular analog and digital cases, because we are not going to be performing any analog structurization, or we are not going to be performing any RTL coding also. But we should know that information such that when we go to the further stages, that will be helping me. Like there is a term called as logic restructuring. How the tool is modifying that particular cells, I should know it. To know that particular information, we should know that particular, if I want to develop a mux, can I use directly one mux, or can I use AND gates or NAND gates? So based on that, we can be able to modify that. Similarly, off adder also. How we are going to be structurizing a single circuit or a breakdown. So during that breakdown, which particular gates you are going to be using? Okay, NAND gates or AND gates. Similarly, you can also use muxes. So that developments will have a variation. Okay, so based on this particular, you will be having in ICs also, you will be having first is like analog design explanations, or let's say, and also digital design. So in analog design, you will be covering about manufacturing process and also second order effects. This is key required for your growth, second order effects. Okay, so when you go as your, if you say physical design, it's not only physical design we will cover. Okay, we will cover physical design, basics of physical verification, STA concepts. If you are going in industry, you might go to your power team also. During that particular time, they will ask more and more related to this current equations and everything. Okay, so that's why how this effects are coming, current equations, everything, you can be able to get it aware. Okay, and in digital designs, you will be covering about binary to hexa, all that particular conversions, K maps, and also you will be touching about that particular um, cell development, we can say, using different logics. Okay, that means like I want to develop a mux with respect to what all logic or other cells I can be able to use it and develop it. So all this you will try to do it, but here majorly we are developed, or let's say we are concerned on this particular third section only, because it leads to a concept called as I said, logical restructuring. Okay, grouping of cells, ungrouping of cells. Okay, if I know that how the tool has grouped it, I will be able to understand it. So that's why this is kind of like required for us. RTL people will more be required for this, but for us, we for our understanding only we need it. Okay, don't we go any very depth of this particular analog and digital for us. Okay, because our part is not in this particular sections. It is just only for understanding only during the optimization techniques. Okay, clear so far for everyone? So now, next major I'll touch is like flow. So now I'm going to be constructing an chip, correct? That is our task. So as I'm going to be constructing that particular chip, do you want that particular chip to be working for a particular task, or do you want that particular chip to be working for other tasks also? Multiple task preference. So there are some chips which will be working for particular task only, right? Yes. So that we call it as ASIC. Okay, application specific integrated circuit. That means it will be opening, or let's say when we go for an hotel, automatic door opening is there, right? So that means it is only task is like opening and closing, specific task. Now at the same time, I want to develop it in such a way that it has to open and it also has to scan me. Okay, unidentified objects, right? So for all that, I need to scan it automatically. So that means I'm going to be adding one more task to it. And along with that, I'm adding one more task. How many males, how many females are coming in? So that means more and more specifications are getting added into it. We call it as SoC, system on chip or silicon on chip. Okay. So for example, your phone, if we take, what is your purpose of the phone? Basic purpose of the phone? For calling purposes, right? To talk with your closed ones in different locations. But nowadays, what is happening? Along with that particular, we are added video calls, right? Along with that, one more feature is like in that video call, how we can be able to modify the backgrounds. So like that, we are adding more and more features into that particular. So that is application to internal software. But for that particular software support, we need to have a chip support also. If the chip is not supporting, then whatever the software I develop, that will be waste, right? So that's why based on the requirement of the customer who is giving, so we have to develop that particular chip. Okay, whether it is application specific or SoC. In simple, your laptops, your phones are SoCs, right? Whereas when we talk about your door openings, those are application specific. Okay, so when we have flows, we have two structurization, ASIC and SoC. The flow for both of them is same, but in SoC we will be having one extra step into it. Okay, so now how many of you are good at coding, or let's say a basic knowledge of coding? In our particular engineering, we have done some kind of codings, right? So when you write a code, or let's say someone is asking you to write a code, what is the first step you have done? Okay. Okay. So directly you are telling us the coding part, correct? Huh? Before the coding part, you have done something. Flow chart. Yes. The first key requirement whenever I get a question, we if I write starting the code, I'll get confused somewhere in between. So first I need that structurization properly to be done. Based on that particular structurization, if I develop it, I will be in a good state. Correct? Or else where I'm getting confused, that will be again a bigger problem. I'll get confused if I pass it to my friend. He might not understand. Again, he will see it from the start. So that is like waste of time. So the same way here also, the first 10 key requirement for is flow. How I'm going to be developing that particular chip. Randomly, I can't switch the stages, right? So for that, we need is like a flow structurization. The first one is like idea, or we can say specifications. That means you are developing the chip for what purpose? That is one requirement. Second requirement we'll say is like major key terms, PPA, power, performance, area. So what is the dynamic power consumption of that chip? What is the frequency at which that particular chip should work? And also what is the area of that particular chip? So if I'm using it in my mobile phone, can I have a bigger chip size? No. But if it is in my laptop, I can be able to adjust it, right? So that's why based on that particular requirement, the area of that particular chip also should be provided, or let's say decided. So that's why when you are getting this particular specifications, you should get is like purpose, power, performance, and area. These are the first and foremost key factors which you needed from the customer side. Okay, or else whoever is giving us that particular project, they have to provide this info. Then only I can be able to quote it and then I can be able to perform it. So now I got that particular specification. Is it provided to only one company? No, it will be going to multiple companies. So now on what basis I'll get it, right? There will be a bidding process for this also. Even our particular companies, every company to get a project, they will do bidding. Okay, whose cost is less, I'll give it to them. Correct, now? So the case comes over here is like to get that particular cost estimation, architectural design engineers will be used. Architectural designers. Okay, what this people will do is like based on this particular performance or let's say purpose, they will estimate what all logics are required. That means in this particular area, what all logics are required, whether I have that logics, can I develop that logic or not, or do I need to buy that logic? Okay, so that means if I'm developing that logic, what will be the engineer cost? If I'm buying that particular logic, what will be the cost of that? So he will estimate each and everything and he will come up with a number. That number he will pass it to the sales team. They will discuss with respect to the companies, they will bid it, and now they will get that particular project. Okay, that means the basic outline structure of our particular design is performed by this architectural designers. Okay, clear? So outline everything, they will be able to get an awareness of it and they will perform it and they will quote it and they will try to buy that particular project. Now I got that particular project. Next, what should I do? That means in architectural design, I came to know what all logics I need to develop. Right? So now what is the next step? That logic has to be coded now, right? That means like for example, I want a CPU module. that CPU module, how I need to perform, how other companies are present, I want to modify that or not. That means complete new from the scratch, or whether I need to develop apart from that anything new. If anything new needs to be added, that means I need to add extra code to it. That for that coding we have RTL designers. RTL represents full form. What is the full form of RTL? Register transistor logic. Okay, so it's basically your dot v, dot sv, dot vhd. In this particular formats, they will develop that particular coding and they will provide it. Okay, in your Xilinx you have done a very long coding and everything. Engineering last year, I think, so that will be there. Huh? No. Okay. So you have that particular RTL coding available. Okay. So now I have written that code. I have to validate it, right? So for that particular validation, what I need? Verification. So the next step comes is functional verification, or we can say formal verification. Functional verification or formal verification, or we can say design verification also. Any terms we can be able to term it. So that means whatever the code I have written, I'm going to be functionally verifying it. Okay, functionally verifying it by using multiple test benches or UHD format. So there are different languages for that again. So by using the equivalent tools, we will be validating all of that. Okay, so for example, I think so like Questasim, like that there are certain tools. By using that, we will validate this particular functionality of this particular RTL code. So now after functional verification is passed, what is the next step? If it is failed, I'll root back to the RTL designer. If it is passed, I'll move forward. That means it is passing. My next step is with respect to that RTL design, I have this particular logic separations, right? For example, in your design, or let's say in your phone itself, you have network module. We'll take only one basic example, network module and CPU module. Okay, two different. So is the frequency at which both of them are working is same or different? Network
Different.
module and CPU, is it same or different? Sorry?
Different.
Different. It is not the same. CPU should be working with highest frequency. That is like 1.2 gigahertz or 2 gigahertz. That frequency the CPU has to be working. If it is working with lower frequency, your complete functionality will be affected, right? CPU is the main heart of your chip. So if it is working with lower frequency, complete chip will be disturbed. Okay. So now when we are talking about network module, it is used for only receiving that particular data. Correct? I don't need that much of frequency. Only when I enable 5G or let's say internet, according to that, the frequency might change. Okay. But apart from that, we will be having, there is a difference in that particular frequencies. And also one more case we will look. Do you want your phone to be working for a longer duration or shorter duration? Huh? That means I'll turn on within 2 to 3 hours, my battery will be drained out. We want is like longer duration working, right? Obviously, we will look for that higher battery backup times. Now, if you have turned your display always on condition, is your battery backup be good or bad?
Bad.
Bad. So that means I need a power control for that also. That means if after a certain duration, if I'm not using that particular display, it should be locked. Or let's say it should be reduced. Brightness has to be reduced, or it should be off state, kind similar to an off state, it should go. So that means I need a power controllers for that. Voltage differences. That means when the display is turned on, the voltage requirement to that particular display, and when it is in sleep mode, the voltage requirement, will it be same or different? Different. So the strategy also I need to provide. Under which particular condition, which voltage value I need to provide. Right? I need to develop all that particular cases also. With respect to performance I need to create, and also with respect to the power also I need to create it. So we have stages called as CLP, conformal low power, and also constraint development. Constraint is your timing constraints. That is frequencies, all that will be fixed by this particular engineers. We can say it as STA also. Okay, I'll modify this as timing constraints. For our understanding, it is basically an SDC file development. Synopsis design constraints. Timing constraints file will be constructed. But we are not going to be using SDC file. We are going to be using a file called as MCMM file. Multi-corner, multi-mode. Okay. So, in our particular case, okay, that again I'll touch it. What all we are going to do also. Let's list the flow first. Okay, clear so far, right? So I have constructed CLP and also have constructed timing constraints. Now, I have done till here is like purely logical. That means your RTL code is present in behavioral. With respect to that only, I have constructed all of this particular information. So I am going to be doing that particular functional verification also with respect to that RTL logic. Correct? So for moving to the next step, I'll ask a question. How many pins are present for a D flip-flop? D flip-flop. In a D flip-flop, how many pins are present and what are those? Okay, input is D, output is Q. That's it. What is a flip-flop? What is a flip-flop? Okay, what is a register? Okay, what is the difference between combinational circuit and sequential circuit? Number of inputs is equal to number of output. Huh. There is no feedback output from the inputs. Okay. Sequential circuit is having the feedback from the output to input. So now that is like partially I can say, but the major difference between your combinational and sequential is not there.
Arc pulses.
Sorry? Your sequential element will store the data. CP pins will exist. Clock pins. right? So if this clock pin is not present, it is like your combinational circuit only, right? So basic, your combinational circuits will not store any data, but your sequential elements will store that particular data, right? That means rise edge to rise edge. When you're talking about flip flop, edge to edge basis. When you're talking about latch, level to level basis. Correct now? So during that particular duration, my data is getting stored. And the next cycle, my data is getting released. The new data will be stored. So like that, this particular registers are basically a storage devices also. We are seeing RAM, right? Memories. You have memories. So those particular memories are used for what purpose? Storage. So that means internally it will be having multiple this cases only, right? Register kind of scenarios. So that's why now. So with respect to D pin, we have is like D, C, P, Q. Any other pins? Online students, you can also say. Any other pins? If you're not able to say, you can type it also, no problem. You have a chat option. No? How do you clear the data present in your flip flop?
Reset.
Yes. Okay. So now I'll ask one more thing. So how many of you are aware of that particular stuck at zero, stuck at one, ATPG, MBEST, like that? Any terms you have heard about it during your engineering? No? Okay. So there are few terms called as all that particular ATPG, JTAG, LBIST, MBIST, stuck at zero, stuck at one, all that we will be having it. Okay, those are coming under a term called as, or let's say a stage called as DFT, design for testability. Heard about it? No. Engineering, no. Engineering, there is a subject, or let's say one particular chapter for DFT only. Okay, there is a concept of DFT, design for testability. So, what is it DFT people will do? It's testing only. So even in functional verification, I'm doing testing only, right? Now, what is the difference between that?
DFT engineers will include something in the chip so that it automatically tests itself after manufacturing or something.
Yes, correct. So whatever I said, right, or let's say we have said we informed also. That is like JTAG, ATPG, LBIST, MBIST, all from all these four, they will choose which particular module I want. Automatic test pattern generation, ATPG represents. Okay, I know only that because I'm not a DFT guy. Okay, so I know only that particular ATPG related. But in my project, I used to have LBIST, MBIST cases also, which I will not see into that in depth. Whatever the, if I'm seeing any violations, I'll provide a feedback to the DFT engineers. They will fix it and give it to me. I won't go in depth of that. As it is not coming to me, I'm not touching it. Few people have an interest, they will learn it. I'm not saying no to that. I don't have an interest. Okay. So now, when I am having a functional failure, there are millions of cells available in your design. To find out exactly where that particular failure is coming from, root cause of that failure, is it easy or difficult when I do functional verification? Functional verification is like you're passing the test bench and you're getting the output. Okay, it is processing completely and it is giving you that particular output. Now where exactly that failure is coming? to find out is it becoming easy or difficult?
Difficult.
It will become like a difficult case for me. Now I'll divide it into small cases. My overall 1 million, in that I have divided into small circuit. Okay, I split it. And now I will validate at each and every circuit output whether I'm expecting it properly or not. Then I can be able to easily find out the root cause. Yes. So that is what DFT will do. Okay. Designed for testability. So what they will do is like, so they will fix certain amount of registers called as scan chains. Okay. Back to back flip flops will be connected, and I will pass one data, and at the output, am I expect the expected data is coming or not? I will check it. If it is expected data, then I will skip it. If I am getting a non-expected data, what is the root cause? That means in that particular certain cells only I need to validate it, right? I don't need to look for all the circuitry. If I fix that, the most probably the remaining will be fixed. Okay. So that's how this particular DFT will be working. Okay. So that means when I'm going for DFT, your SC pin will be equal to 1. Okay. So first, there are two types of circuitry. One is like D, CP, Q bar. Okay, reset is like if you want you can have it or else not. So when we talking about D flip flop itself, with reset, with SISC, without reset, only D pin related. Okay, so like that we have different types of logic. Based on what is required, we will use only that circuit. Okay, now if I have only R2 cell, okay, if I have only R2 cell, it is a functional cell, purely functional. Okay, purely functional cell. Whereas when we talk about R1 cell, it is a scannable cell. Okay, that means when SC is equal to 0, when SC is equal to 0, it is a functional. When SC is equal to 1, it is a scan mode related or test mode related. Okay, clear so far? So now when SC is equal to 0, I should get the data, right? From which pin I will get the data? Okay, so first is like D we know normally. SI represents scan input, SC represents scan enable. Okay, SI represents scan input, SC represents scan enable. That means like the the circuit is working under which mode is controlled by the SC pin value. Whether it is a functional mode cell or a test mode cell, based on that particular pin value, we will be able to design it. Okay, so now when SC equal to 0, the data which I am getting it will be from which pin? D pin or SI pin? When SC is equal to 0, you will process the data whatever you are getting from D pin. Okay, as I said, it's a functional mode related. When SC is equal to 1, test mode. So that means whatever the data I am getting will be from the SI pin. So now I have to implement. So initially, whenever we write the RTL code, we will write it with respect to R2 kind of scenario only. Only with respect to the functional cases we will write it. Because I have my functional, whatever RTL code I am writing. If I think about DFT and if I write it also, it will become more complex. The number of pins increase. As the number of pins increase, I have to maintain the connectivity and everything. So it becomes a complex scenario. So that's why initially when we write that particular RTL coding, we will write it with respect to the R2 case, only functional case. And later on, we will take the help of DFT and synthesis tool. We will modify R2 cell to R1 cell. Okay, so that is why what happens over here is like we can say synthesis and DFT is in parallel. Okay, or else after synthesis, DFT incremental synthesis also we can see. Okay, or else we can say DFT synthesis also. Anyways, it is going to be perfectly fine. How you are going to be implementing it, that will have a change. That means if I am saying DFT prior to it, that means in that RTL code, as we said, the extra module ATPG or JTAG or BIST, that logic will be implemented. Okay, in the RTL coding section. And in the synthesis only, this conversion will happen. That is R2 to R1 conversion will happen only in the synthesis stage. Okay, for that, again, DFT people should provide certain configurations. Based on that only I can be able to convert. I can't randomly implement it, right? Based on certain rules, whatever the DFT people is providing, I'll follow those rules and I will implement it. Okay, so that's why DFT I'll not touch. Only synthesis I'll cover. Okay. So after synthesis, that means now in synthesis stage, whatever we have written in RTL behavioral model, it will be converted into a structural format. That is, it will be having now its gate representations. For example, in RTL coding, you have is y equal to a and b. In after synthesis, you will be seeing is like how many input AND gate it is? Two input AND gate. Based on the libraries, input library which you provide, you will be seeing like this. Dot A1 of A1. Let's say A. Dot A2 of B. Like this, you will be able to see. Okay, conversions. So behavioral code can be physically constructed. The answer is no. Okay, I cannot be able to perform it directly. So if I want to perform it, I have to construct that particular AND gate also. Correct? So to develop this particular AND gate, there is one more concept called as stick diagrams. I'm not sure how many of you are aware of it. There is a concept called as stick diagrams. For this particular gate development, stick diagrams will be used. Okay, so that means like where exactly the pin should be placed, in which particular metal layer kind of scenario, how the structurization of that pin, how the internal functionality of that pin is going to be performing, all that kind of information will be available in that stick diagram. Okay, so by using the stick diagram, analog design engineers will develop it. Okay, they will develop the standard cells. Okay, standard cells are your basic circuits, or let's say simple circuits, like your AND gate, OR gate, half adder, full adder, and there are some special cells also, like level shifters power gates. Like that, we have different categories. All that simple circuits will be constructed by the analog design engineers. Okay, that we call it as standard cells. And one more is like macro designers, we can say, or IP designers. The PLL, macros, the memories, all that means the complex circuit will be coming under the IP designers. They will structurize it and give it to us. That's why I said in the architectural design, we will be able to get to know whether I need to buy that particular module or whether I have it existing in mind or should I create it. If it is with me, the cost is less, right? It's already developed, I'll reuse that. If I don't have it, then comes the question, should I buy it or should I construct it? Then cost comparison. Developing is like less costly, then I'll start developing, such that I can use that particular module in the other projects, upcoming projects also. If I buy it once, I have to renew it again. You won't simply construct it and you will leave it, right? It's like profit I need to gain, company rules, right? So I'll develop for this duration, or let's say I'll give is like for this project you use this agreement. Next project, if you want, pay extra, I'll give you. Agreements will be there for that also. Okay, so that's why this particular gates, that is your transistor level, will not be observed in physical design. Okay, because analog designers and IP designers have already structurized it. I'm just going to be using it. Okay, so after this synthesis stage and DFT, you will directly jump into the physical design. In physical design, again, there are multiple steps that also we will discuss. Okay, after this physical design, it's like near to the sign off, where we are validating and closing it. Manufacturing. After manufacturing, it goes to a stage called as post silicon validation. So after manufacturing, we might see some failures. Once that particular building is constructed, then only I can be able to see, okay, where exactly there are cracks and everything, right? If I don't construct it, if I see in an imaginary way itself, it will not work. So that's why after I complete my sign off stage, I'll manufacture it and I will validate it. Is everything is going in a smooth way or not? If it is not clear, or let's say if any failures are coming, we will provide a feedback to the physical design. And again, they will say, physical design engineers, the leads, they will observe which type of violation I'm getting it. Whether I need an update in the functional or whether I need an update in the metals, that we will modify it and redo it. Okay, version updates we can also say V1, V2, V3, all that versions. So those are also getting structurized based on this. Once everything is passing, your chip is passed to the customer. I'll just write customer, no need of chip. Because if manufacturing chip is constructed, right? After post silicon validation, if it is passing, it goes to the customer. If it is failing, it goes to the physical design for restructurizations. Okay, clear for everyone? So this is ASIC flow. Whatever we have discussed right now is ASIC. That means I'm going to be developing that particular chip for a particular task only. So now when we talk about SoC, what is the difference? What is the difference between SoC and ASIC? Multiple ASICs combined together will be SoC. Now add one extra stage, that is RTL integration, which will be, we can say here itself or before this particular stage also, or after this, RTL integration. When you are talking about SoC structurization, so now whenever you have a mobile phones, right? So there are multiple modules. Can a single engineer write out all the RTL code? No, right? I'll split it into separate engineers. So that means one engineer is CPU. In that, he can have multiple other sub teams also. Same like for memory. Okay, one engineer. So every engineer has separately created this netlist. I have to integrate all of them into single one. I have to use all the separate modules into one complete structure, correct? That is what we call it as SOC. That merging of different netlists, we call it as RTL integration. Again, RTL integration, you will process the same flow. In ASIC, only one, sorry, in SOC, we will have one more extra stage, that is RTL integration. Okay, this is the difference between ASIC and SOC flow. Okay, so now in our particular stages, or let's say in our particular course, we will discuss about synthesis, physical design, and sign off. Correct. And in this particular sign off, we will majorly focus on STA and basics of physical verification. Power related, I am not going to touch it. I think so that is a separate course or something. I'm not aware of it. So power is a separate. Okay, so we will cover STA in detail, physical design in detail, and synthesis and physical verification of what all is required, that we will cover it off. Okay, clear? Right. Now let's get into the back end, that is synthesis. First one, synthesis flow. So how the explanation, okay, here it goes into two different parts. One is lab and the other one is theory. Okay, your theory sessions will be conducted only in the weekends, that is Saturday, Sunday. Your labs will be in the weekdays. For those who are working in the weekends, you will be having labs. Okay, so it will be offline and online both. Whichever you prefer, we will be able to do the same. Okay, now during that particular theory classes, whatever we explain, you have to validate in the lab. In the lab, mentor will go in one flow. If you follow that particular flow, it's a waste of money. Whatever you paid, it's like blindly following. There is no use. We don't want engineers in real time. We don't want engineers who blindly do what we say. We want is like their logical thinking also. Sometimes what happens is like, I'm a manager. I'll get confused. So I need opinions. So from whom I'll take the opinions? From the team members. That is a good relationship. I'll take your opinion and I'll try to process that also. If it works, we will implement it. If it is not working, then I'll say is like because of this scenario, we might see issue. Then you will try to validate it from your end and you will prove it wrong. That cases also is acceptable. Some engineers will accept, sorry, some managers will accept, some managers will not because of their pride. Okay, we can't do anything for that. So this is like politics will be there everywhere. Okay, so now here also the thing which you need to do is whoever the trainer might be, you have to validate each and every statement what we are teaching. That means your homework also should be there. You have to come up with more questions such that what will happen is like it creates a more interactive, and what we teach you have to implement it in the lab. If any concept is missed, you have to ask a question why it is missed. Okay, so whoever the trainer might be, the first, or let's say the flow, how they might teach is like what is the goal, or let's say why I need to perform synthesis. Okay, from that particular synthesis stage what I'm going to be achieving. This is the first key requirement, right? If I don't know what is synthesis but I'll directly say is like this is the process of synthesis, do you agree? No, right? It will be confused only. Are yaar, what I am doing, that will be there after a shorter duration, that should not be there. So that's why the first and key requirement is like goal, what exactly I'm doing and what I'm trying to achieve from that particular stage. Okay, that is your key requirement. So goal is like here majorly converting the RTL code to gate level netlist. Converting RTL code to gate level netlist. So your RTL code, whatever we have written, that is .v, .sv, .vhd, is a technology dependent or technology independent? If it is wrong also, you have to raise your voice. Okay, then what happens is like it boosts your confidence. One. Second one is like whatever we were thinking that gets erased and new data comes in. If we keep on thinking in our mind, what will happen is like we will store only that info. Whatever we are trying to say, that might not overlap. Okay, so that's why even if it is wrong, don't think about your friends. They are not going to get you a company, or let's say they are not going to pay you. This is learning. Don't see about what others will think. You have to be focused on yourself only. Sometimes what happens is like he will gain the knowledge from you and he will succeed. You will be in that stage only. You only helped him. But when you ask him, is there any openings? kaun hai yaar tu? Right? That possibilities are there. Because this is the real. Friends also nowadays is like money minded. Earlier friendship is different. Now the friendship is different. That's what I feel. Okay, there are few friends also which will be in good terms, but 90% are like cost. Okay, so now coming back. So first one, your RTL code is like completely behavioral format, right? So as we are talking about behavioral format, y equal to a and b conditions, that is technology independent. Okay, first, what is technology dependent and what is technology independent scenarios? What is technology? So day-to-day update, instead of saying that, I'll say is like you're buying your mobile phones now. When you buy that particular mobile phones, you will be seeing that a Qualcomm processor which is working at 2.4 gigahertz, 3nm technology, 2nm technology, 14nm technology, like that we are seeing some terms. that is your technology node. That 14 nm, 3 nm, 2 nm are your technology nodes. Those are basically your transistor, that is your drain to source distance. Okay, in your CMOS, right, we have drain and source. The distance between that, or let's say PMOS to be exact, the distance between that drain to source, we call it as technology node. Okay, currently we are working in 2 nm. So we still have projects which are running at 90 nm also. Okay, if you take about the ISRO projects, right? No laughing, yaar. They are working with higher technology node. It has higher stability compared to a lower technology nodes. Because we want that particular chip to be working in all the conditions, internal and external. Whatever we are developing, when it goes to external, can we give a guarantee? No. The one of the most stabilized is ours only, ISRO. Okay, that we can say proudly. Okay, so at the same time, lower technology node will reduce my area, but the problems is like when it goes external, I might see more and more failures. I need more validation for that. So that's why we have higher technology nodes manufacturing also, lower technology nodes manufacturing also. Again, based on where I'm using it. Okay, so now this 14 nm, 13 nm, 4 nm, 90 nm, this is like drain to source distance. Okay. Now, that means this drain to source is present where? In your transistors, or let's say it is present for me when in my case in a standard cell. Correct? This standard cell is constructed by analog design engineers. Okay, analog design engineers are for developing that small circuits. We will use that small circuits. That means for each and every technology, they have to develop that particular circuits. If they don't develop it, what will happen? I cannot do. Physical design is not processing. Okay, we cannot map it anywhere. So that's why the analog design engineers will play a key role on the structurization of that standard cell. So when I'm saying structurization, that means the outline kind of, that means the shape and the size of that particular standard cell will be provided. Where that particular pins are present, that will be provided. Now the time taken from this particular input to output, that also I need to know. Propagation delay we will state it. Okay, so this keyword also I should know how much time it has taken from input to output. So you know about flavors, right? LVT, HVT, RVT, low threshold voltage, high threshold voltage, regular threshold voltage. So based on that particular, again for each and every cell, 3 different flavors or 4 different flavors. So according to that, your timing calculation. So that means I need some files also. So that means as I'm saying the cell name and 2 underscore HVT or SAED 32 and 2 underscore HVT. It represents that I'm going to be using the cell from the vendor who has structurized that particular cell for the technology. I can't use randomly any name. I have to use the same name what the analog designers has released. That means we are terming it as vendors. From them we are buying it and we are using it. Okay, so from the vendors I'll buy this, the same naming I will implement it. So if I implement it, it becomes a technology dependent. If I use a global terms, Okay, if I use global terms, that is like, for example, we say is like y equal to a and b. One condition. Another condition is like I have is like a RAM 32x8. I want to use this particular cell, but I want to use that cell, but from where I'm going to be buying it, whether I'm going to be developing it is not finalized yet. Can I stop using this for now? No, you should not stop. You should use it. Okay, but the only thing is like when you go for physical design, it will be able to give a problem. Okay, we will map it. The naming, I don't have any cell with RAM 32x8. Okay, I don't have any cell with RAM 32x8. There is no library cell. But now what I need to do is like in synthesis stage and as well as in the physical design, I need to map it. Which cell I need to map? How that particular mapping structure will go. Okay, that kind of analysis is also required for us. Okay, so all this kind of scenarios we will cover it during that particular advanced classes. Okay, first is like RTL code to gate level netlist. This RTL code is technology dependent or technology independent? Independent. And gate level netlist is technology dependent or technology independent? Dependent. That means in this particular synthesis stage, I'm ensuring that I'm going to be getting a netlist which will be technology dependent netlist. To get that particular technology dependent netlist, I should use certain files. What files I'm going to be using? All that we will be covering it during the advanced classes. Okay, so how that particular process will go, what all optimization techniques are present, all that we will be able to cover it. So see, this synthesis stage is also having a flow. Okay, majorly three key terms: analyze, elaborate, and compile. Okay, analyze, elaborate, and compile. So analyze represents validating. So what all validations we are going to do, or how we can be able to get that particular netlist validated, that steps we will be discussing. And in elaborate stage, how your netlist is going to be elaborated. Elaborated is like expanding and validation. Okay, when I expand it, whether that particular equivalent information is present or not. If that information is not present, then what is the error I will face? How do I fix it? That also we will be discussing. And next is like compile. Compile is the finalized stage where your mapping and optimization will happen. Okay, we can say it as mapping and optimization. In this particular compile stage, you will get that particular gate level netlist with timing optimized designs. Timing will be optimized, power will also be optimized. Okay, so initially these three steps will be with respect to your RTL code. RTL designers has developed, no? You will use that code and you will use it. So have we implemented any DFT patterns over here? No. So now comes the next stage called as scan configuration. You will load. Loading the scan configuration. That means that DFT people will provide certain scripts. We will load all that particular. And next you will do is like incremental compile. Here in this particular incremental compile stage, we will have that particular conversion. That means functional flip-flop to a scannable flip-flop consideration it will perform. Okay. And once we have done all of this, we need to again confirm it, right? Before I pass it to the next stage. So what all files we will extract, how to validate all of that information, that also we will be discussing. Okay. So as this is a demo, I'm just restricting few things. But when we go to advanced, we will be explaining each and every term in details only. Okay. What all is required for that, or let's say fresher level, we will be discussing all of that. Okay. And some concepts we will be going very depth. Okay, clear for everyone? So after this, it's basically your files extraction and checks. Okay, so this is all about your synthesis stage. So here in the I've given only one goal, that is like converting RTL to gate level netlist, but there are sub goals also which we need to check. Okay, what all sub goals will be present, how we can be able to achieve it, or let's say fix that. If I'm seeing any violation, how do I fix it? Those particular tracking also we will be performing. Okay, and in here which we will be covering it in the lab session is like tools which we are going to be using is design compiler from Synopsys. So there is a from Cadence also genus that we are not going to be. Okay. So majorly we will rely on this design compiler. If you have Fusion compiler, right, you can work on that also. FC shell we will term it as. So FC shell is a combination of all the individual tools. Single tool is enough to do from RTL to your sign off. I don't need multiple tools. That is Fusion compiler. Again, that is from your Synopsys only. Okay. So before moving to the next stages, we will take a break and then we'll come back. Okay. Break of 15 minutes, back at 11:15. Online students back from break. Okay. Okay, so let's move forward. So the next stage is physical design. Okay, the next stage which we are going to be discussing is physical design. So till this particular stage, whatever we have discussed, right? It is purely all that information is in a logical structurization only. That means in file formats. We cannot be able to see the physical information of it completely. That means how that particular cell shape is present, where it is placed. So that kind of physical information you will not be able to see it. So in physical design, you are going to make it happen. That means what is your task is like arranging that particular cell area properly. That means, for example, in a room, the architectures, right, what they will do, they will make sure that I will get a proper exposure to each and every one. So the table locations it might be, or let's say the monitor locations, everything they have to place it, plan it, and place it. The same way we are also going to do that. Okay, we are like a civil engineers in simple. They will be working in outside world, and we will be working in AC. Okay, this is the major difference. That means here comes the floor plan, power plan, placement, CTS, and routing. The most and relaxed stage is routing, because that is the final one. Okay, so till that particular stage, you will be having multiple headaches. Okay, so any work we will take it, the headache is there, but how we take it in a challenging way, that is a role. Okay, so here we will be facing is like from one project to another project, I will be using the same module. I'll be using whatever I have used, I'll use here, but I'll see new violation. Why I'm seeing a violation? That is a challenge. That how I fix it, that is what your real challenge is. Okay, we are going to be using the existing module itself. We are going to be using the existing, however I placed in the previous project, the same methods I'll use there. But now I'll see different violations. According to that, how I need to modify that kind of scenarios. Okay, so now I'll give in brief of each and every stage. In floor plan stage, okay, in floor plan stage, the first and foremost, we are going to be creating core area, die area, or let's say core and die boundaries. Core and die boundary. And after this, you will be performing a step called as port placement, macro placement, and after this, we will be having that particular physical cells placed. And fixing the macros, or let's say we will have some more placement objects, we'll say, like blockages, bounds, and multiple others. Okay, so there will be some more also. I've listed only few things over here. So first is like core and die boundary. That means die boundary is the chip. Okay, or let's say your outline structure. It can be, or let's say your physical design whenever you construct, right? You will be working in two levels. One is SOC level and the other one is block level. SOC level, experienced people. If you get in the starting itself, if you do that particular project for one block, if you do it good, right, you might be promoted to SOC level also. With less experience, you can work in SOC also. There is no rule or restrictions of this particular. There is no restriction for this particular SOC level or block level experience. Okay, if we are performing it good, then we can be able to work it properly. So your shape of the design can be in any structure. That is L shape, T shape, U shape, rectangle, any puzzle shape also it can be able to have an existence. Okay, there is no compulsory rule that you have to follow this particular shape only. Okay, the outline boundary is the die and the internal boundary is the core. The intermediate, or let's say the spacing between this die and core, is your core IO region. Okay, so now in this particular space, you will be placing the ports. If we are working in block level, you will be having ports. If you are working at SOC level, you will be having pads. Okay, based on the level we are performing it, the terminology changes. Whether I need to place the port or whether I need to place the pad, that will be having a difference. Ports are pads, basically your input output, output to input. Okay, your interface. We will be having this. So in your core area, all the cells, that is your macros, standard cells, physical cells, all that will be placed inside your core area only. Okay, outside that core boundary, no cells will be placed. Inside the core boundary only, you will be having that particular cell placement. So during that particular floor plan stage, when I create this core area and die area boundaries, we have some more information called as tracks, side rows, tiles, okay, and double back. Like this, we have multiple other terminologies that will be explained. That means while I create this core area and die area, I will be creating this too, tracks and side rows. Guys, just give me a second. Okay, sorry guys. So here, when we create this particular core area and die area boundaries, okay, along with that, your tracks and site rows will be created. What are tracks? What are site rows? How they are created? How it is related to our particular standard cells? And what is this tiles? All this particular individual steps we will be discussing it. Okay. So once everything, the base is structurized, and after that only we will do that particular next stages. Okay. So that means once this core area diarea gets created, that means your tracks and site rows are created, your ports will be placed, and along with that, your macros will be placed. Okay. What are macros? Complex circuits, basically your memories, PLLs, all that will be coming under a macro terminologies. Okay, so for placing this particular macro, we have certain rules or let's say guidelines. Okay, why that particular guidelines has to be followed? What happens if I don't follow that particular guidelines? So there's kind of, you will be performing lab also. Okay, one set you will be using the guidelines, one set you will not using the guidelines. That is your task only. We will just say it's like you have to do it. If you do it, you will learn it. Okay, we will guide you. We can't feed you, right? So we will guide you as much as possible. If you do it and come up with questions, we are very much happy. Okay, so next is like macro placement, and there are some other standard cells or let's say physical cells we will be having, like decap cells, tap cells, tie cells, spare cells, filler cells. So all that, when it will be used, where it will be placed, all that also we will be discussing it. Okay, and similar like that, we will be having this blockages, bounds concept also will be covered. Okay, clear? So once this particular floor plan is done, that means my major goal of this particular floor plan is to create the boundary and place the macros such that I will be having enough area for the standard cells to be placed. That will be the goal. Okay, effective way of macro placement such that your area will be utilized properly. That will be the goal of your floor plan. And after that, we have this power plan. We are just going to be sourcing a script for this particular power plan stage. We are not going to be developing any strategies or anything. We are going to be use the existing strategies. The reason is because when we are discussing about power planning, that means I need to distribute the power network, right? Power and ground, I need to distribute it. So when I'm distributing it, I need that particular, for that power, I will be having a current density value. If the current density value is greater than that particular whatever the metal is going to be support, then what is the problem I'll face? Electron migration, EM. Okay, you will face this EM violations. So that's the reason why. Am I not audible to anyone, or is it only me? Am I audible now? Guys, am I audible?
Yes, yes.
Okay. Okay, perfect. So now the next is like, okay, so from where I got disconnected? Or is it continuously audio is there? Guys, if you say me, based on that, I can be able to move forward. Okay. So from start, I have it. There is no disconnect. Am I correct? Yeah, perfect. Okay. So the next step for this particular power planning is that The current density, based on that particular current density, the width adjustments has to be there present. Based on the number of circuits, the power has to be satisfied. That means the strategy development. All this will lead to another bigger concept. So by to do this physical design and also power planning is a very longer term process, which we will not do it. So what we will do is like there will be a separate team for this power. They will develop it. Okay, all these particular scripts, whatever we are saying, floor plan, there will be a script. Power plan, there will be a script. So that means there will be a CAD team. They will develop it. We will validate it. We will provide a feedback. They will adjust it and reshare it. Okay, version 1, version 2, version 3. Whatever the fixes I am providing, they have to do it and they have to come up. If they don't do it, that means I need to find another solution. Okay. So as much as possible, we will try to implement everything in the CAD structurization. Okay, a scripts will be developed and we will use that. Because in the next project, I'll not see that violation. If I don't implement it, what will happen? Again, I'll see the same issue and I'll be in problem. Right? So to overcome that, the scripts has to be updated. Oh, okay. Okay. So we will source that particular script, we will validate it. So for validation, the connectivities, how that particular power plant is distributed properly or not. That means the major checks will be like EM, IR. Okay, EM and IR will be checked. So in this particular power plant stage, is my standard cell placed? No, only macros are placed. With respect to that particular, if I get an understanding of that particular bigger circuit's power consumption, remaining area, the power is getting distributed properly or not, I'll analyze it. Okay, so that means if my macros are placed in this particular sites, your power planning will be distributed horizontally and vertically. VDD, VSS, VDD, VSS, like that it will be forming. Always a pair. Okay. So apart from this macro, where the standard cells are getting placed, am I seeing IR drop also or not? If I am seeing IR drop, it is because of certain issues. What are those issues and how do I fix it? Okay. So this kind of scenario based is what we will be discussing. It's not like only theory part. We will give you a scenario and based on that particular scenario, we will say is like this is the possible fix. In ICC2 tool, I cannot show you this violation. Okay, I can't show you this violation, but I will state is like I'll show you a particular scenario from your design. Okay, and we will say is like because of this, you will see this violation. So the fix should be in this particular. So that kind of scenario based is what we will be discussing completely. So that means if we are touching theory, it's not like complete only theory we will touch. We will also touch the required labs also. What all I need to explain from the lab perspective, what all you need to observe, that kind of scenario we will touch it. Such that when you go to your labs, you will observe that in very detail. Okay, we can't have a work in let's say parallel session. You will do it in labs. I'll explain it in theory. Okay, so that structurization will go. So in power planning, distributing the clock network. Sorry, power network. My bad. Distributing the power network such that you will face is like less EM and IR drop. Here the terminologies comes like rings, straps, rails, bumps. All these keywords will be coming. Okay. Next, and you can say EMIR also. After power planning, we have is placement stage. In this particular placement stage, we are going to be placing the standard cells. Macros, you have to do it manually only. Even though if you have 300 macros, you have to do the manual placement only. No automizations. We have automation methods also, but we prefer of less using that. Because of that particular placement is not good enough, we will not prefer of using that particular automized floor plan. We will do manual based floor plan. Okay. That means each and every macro you will drag it and you will place it. That's how you will be performing it. Okay. So now when we talk about standard cells, I will be having 50,000, 1 lakh, 10 million, 3 million, like that I will be having. Each and every cell I can't be able to pull it and place it, right? That tool will itself take care. Okay, while pulling that particular standard cell inside the core area, how it is getting pulled. Okay, what all optimization techniques it is performing. Like, so here first is like course placement. We have three major categories: course placement, legalized placement, and detail placement. Three major categories of placement stage. Course placement is like global. I'll just push everyone inside. While pushing, there will be some steps. Okay, what are those? Random pulling is not correct, right? While pulling also, I need to take care of few things. For that, what all is required? Input files, or let's say what are the possible ways of skipping the input file, that we will discuss it. And legalized placement is like, I have to make sure that everyone is sitting properly, not overlap cases. Okay. Now, if I'm arranging it in a seat basis, I want you to sit in that seat itself. You can't move that seat location. Okay. So that kind of checks will be done in the legalized placement. And in detailed placement, your there is a term called as logical DRCs and timing. Majorly, this too will be optimized. Along with that, your power and congestion also can be controlled. Okay. In detail placement, logical DRC optimization, timing optimization, and power and congestion optimization. All this will be performed in this particular detailed placement stage. So how that optimization is going to be performed, how you can control it, or let's say how to reduce it, the violations, everything we will be discussing that. Okay, there are keywords like HFNS that also will be touched. Okay, so after the completion of each and every stage, you will validate it. That means whatever you have performed, that is good enough to move towards the next stage or not. So here I'm giving is like very summary based. When we go into the theory and labs, you will do everything in detail. That means like what is the goal, what is the procedure, what all input files are required, what all files you will extract it, which files you will process it to the next stage, or whether it is used only for the analysis, and what all checks I need to do. Okay, so the thing is like for each and every stage, the goal, input files, the process or procedure, output files, and checks. This 5 stages has to be performed. Whoever is explaining, they have to ensure that this 5 stages has to be explained. The way they explain it can be different. Few might use this terminology and explain. Few might say is like in the flow they will explain each and everything. Okay, the way of explanation will vary from person to person. We are not clones, right? Duplications. So person to person it will change always. The way of understanding also will have a variation. Okay, now the next stage is CTS. In this particular CTS stage, you will build the clock network. Okay, you are going to be building the clock network. So that means how that particular clock needs to be propagated, that I will be able to control it. Which type of tree, all that we will be discussing. How to reduce the dynamic power consumption. Where should I place the clock gating circuit? All that we will be constructing it. Okay, again, less manual effort we will try to use it. We will go here with respect to the automized default structurization. When you go to industry also, this manual clock trees are also automized. Scripts are developed. We will use that particular scripts and we will proceed. Modify the values and we will do it. For that modification, what all you need to analyze, that we will touch. Let's say we will use terms like skew, latency. In this particular, the major keywords comes is like skew, latency, min pulse width, and min period. Okay, skew, latency, min pulse width, min period. This will be the major keywords I will be focusing in this particular CTS stage. And the final stage is routing. Your nets are going to be physically routed. Okay, this is about your physical design. Clear, right? Summary based what we are going to do and what you are going to do. You have more homework compared to us. Okay, we will go in one flow. That is like one project we will touch initially. We will explain certain stages and everything. After a certain stage, we will give you another project. That it's completely depending on you. We will give you only support. But if you ask to explain everything from the scratch, we will not do it. Project 1, we will explain everything in detail. Okay, coming to project 2, that is your task. If you raise query from that, or let's say you're stuck anywhere, we will give you a hint, you will process that. Okay, that's how our particular work will go. Okay, if we are not giving a project, right, second project, because of some other, we might forget it. What is your task is to ask. Let's say after CTS stage or after placement stage, you ask that particular why, where is the second project? We might miss sometimes. Human errors, possibility. So you can ask that particular when that particular second project information will be provided and when to develop it. That is your duty. Okay. So everything from our side to be 100% nowhere is possible. I'll be frank enough. So the thing here we want is like communication between the mentors, trainers, and also students. Okay. So if it is wrong, you should be in a position to call us. There is no wrong. We will not say anything to them. If we are giving any task and if you are not doing it, again we will call you. Mutual. Okay. Then only we can be able to gain knowledge. Here again I'm saying, here it's not engineering. What we teach, only that you have to do? No. You have to try by yourself. Okay, that is what here extra. You're paying it for that only. You have to gain extra knowledge. That means you have to do more trials. Okay, different ways to get that particular task done. Okay, and one more thing is like no copy paste. We can't control that, but we can say only thing. Don't copy paste. Be individuality. Okay, so next is sign off stage. Or I'll modify this. First is like STA, static timing analysis. As I said, this timing analysis explanation will be in detail again. Because when you go as a physical design, right, knowing only that flow is waste. Because we are saying is like timing needs to be optimized. That means I need to know how that timing is getting calculated. For that, what all factors I need, how to create an SDC file. So like that, all that particular factors we will be covering it in this STA concept. That is like how to create clocks, clocking information we can say. We will be discussing about clocking information, timing exceptions, few terminologies like uncertainty, transition time, capacitance, fan out, fan in. Like that, we will be discussing few terminologies. And at the same time, we will be discussing about D rates, OCV, AOCV, POCV, modes, corners, scenarios, PVT conditions. So like that, we will be going the concepts in detail for this STA, such that you will be in a position to write your own SDC file also. I'll give you just a design. For that particular design, where to define clocks. You will be able to analyze it and you will be able to write it. Okay, we will explain few, that is like in this particular STA concept, there is a concept called as, or let's say a command in your prime time as well as in your ICC2 synthesis and everything. There's a concept called as check timing. Okay, this will help me to ensure that each and every flip-flop is constrained or not. If it is not constrained, I can be able to validate it. Okay, flip-flop to be working, clock is required. If clock is not reaching, I need a justification, or let's say I need a fix. So that kind of scenarios we will cover it. Okay, and we will see multiple examples for timing analysis. How that particular timing, that is your setup, we have your term called as setup slack, hold slack. Okay, how it is calculated, different ways of calculation, that we will be covering it. Okay, different timing paths we will consider, different multiple clocks we will consider, and we will give you examples. We will do in the class itself. One or two questions we will give it as assignment, such that you will also gain the confidence. Okay, and there is concept like STA DTA. What is the difference between STA and DTA? Okay, static timing analysis, dynamic timing analysis. So what is the difference between them and why do we prefer STA? That kind of scenario based also we will discuss. So here, whatever the concept we are explaining, it will be always be a scenario based. Okay, 80% we will cover it based on the scenarios. Only touching theory, it's waste of time. So scenario based explanation is what you will be able to find it always, such that you can relate it. Okay, and in this particular post layout STA, so there are two concepts again here: pre layout STA, post layout STA. Okay, pre layout STA, post layout STA. In pre layout STA, we will be having that particular SDC constraints related. And in post layout STA, you will be doing the fixes for DRVs, or let's say logical DRCs and slack, crosstalk. All this we will be fixing it in this post layout STA. How the report looks, okay, how the parasitics extraction will be present, all that kind of information we will be discussing it. Okay, and last but not the least, the next one we will be having is physical verification. Here we will be discussing, I'll give only the terms here, LVS DRC, layout versus schematic and physical DRCs. So if we are facing it, how to manually reroute, that we will be showing you. That means how to fix the violation and how to manually reroute it. We will give you an ideology, you have to do it. Okay. So this is how we will be performing it in the advanced sessions. Okay, technical side clear? Any questions, any doubts? Okay, right. So if no questions in technical side, can I ask the admin stuff to join? Online students, is that okay? Or if you have any technical based, you can ask it.
Sir, I have one doubt.
Yeah.
Sir, is this course for particularly for freshers or also for somebody who is looking to pivot from, say, IT industry to VLSI or?
It is like, as I said, fresher. Okay. But
Yeah.
if you do that particular, if you change the swap also, right, this will be helping you. That is like if you are swapping it from IT to the VLSI industry also, this will be helping you.
Sir, will recruiters show any bias for people, say, somebody who is a 4 or 5 years pass out or go pass out? So, will it be a problem for somebody or
No.
it will not,
Uh,
right?
no.
In
So the
terms of
thing is
placement.
like,
Yeah.
if you are newly fresh, okay, you
Yeah.
will be facing problem. I'll be frank.
Okay.
Okay, any industry, it's not only in our industry, any industry, for fresher, it is always a problem. But if you have some gap, we have some companies called as service-based companies. So what they will do is like they will recruit us, they will put the fake experience and they will put.
Okay.
Okay, even if you are coming as IT experienced guy, we will take you under that particular experience itself. But when I'm projecting it to the client, I'll swap your experience. That means I'll not put your IT experience, I'll swap it to another company. Or let's say the equivalent. In my domain, what I need to that experience, I'll convert it and I'll do that. So gap is helpful.
Okay.
Fresher, you need to wait. I'll be frank.
Okay, sir.
Okay. Patience is required in our case.
Okay.
Okay. Related to the management stuff. Okay. Any other technical questions?
Sir, one more thing, if you can clarify. Sir, if somebody is interested in analog and mixed signals domain, so if
Hmm.
they start out in physical design, so can they later switch on to analog design, or will it be difficult, or should they start in a different course, like there is a layout course as well? So
So those two, let's say physical design and analog design, both are different.
yeah.
Okay. So if you get into physical design, yes, in industry, you can be able to swap it later. Or let's say I'm joining as physical verification. Later, I want to switch it to physical design. I'll switch to physical design. Later on, if I want to switch to STA, I will be able to switch to STA also. So interviews, everything will be there accordingly. But for
Okay.
that, if you have the knowledge, then you don't need a course. If you don't have the knowledge, then yes, you need a course
Okay. And
separately.
sir, in physical design, there are more job opportunities, right, as compared to analog layout or design?
Yes.
Okay.
Okay. Any other questions? Okay. Just give us 5 more minutes. I'll ask the admin team to join.
Okay. So, good morning, all of you. Myself, Vaibhav. I think our trainer has provided all technical insights of what is physical design, what you're going to learn, what is industry expectations, and what is the growth in physical design. I will be telling you about how the course structure will go, how the evaluations will be conducted, post that, how you will be getting added into the job support, followed by how we will support till you get a job. Okay. So basically the training that we are doing, just allow me to open the note. Just allow me another 5 to 10 minutes. I will explain the entire process and then I will address the questions in the chat box also, as well as you can unmute and ask the question. Yeah. So the duration of the course is 6 to 8 months. In this 6 to 8 months, the training will be gone in two phases. That is the basics and advanced. The 2 months will be basics, and it will be 4 months of advanced training. What is the difference between basics and advanced? See, when we are taking a batch, right now the people who have already taken admission is from different institutions. I have NITs, I have IITs, and even I have colleges that belongs to university or affiliated by the university. So we make sure that the starting point is same. So that we started from the scratch. That is, we will start with digital design, then PD basics, CMOS fundamentals, then we will go to TCL scripting. Once you go to TCL scripting, you will be requiring the tool that is ICC2, which is a part of Synopsys. So during the basics, we will be covering all these modules that is start from digital PD basics and all. Why it is mandatory for us to start with this basics? It is because when it comes to hiring from our end, companies are very well aware that they are hiring a freshers. The only difference is you are trained over the industry tools rather than hiring someone from Naukri.com or any other job portals, you are a trained fresher. So they are very well aware that you are hands-on over the tool. So when they are hiring a fresher, they won't expect you to have a very real-time project. To give an example, HCL has conducted the interview in which for digital itself, they have spent 1.5 hours. Even the interview was, the position was physical design trainee. They wanted to know how much strong you are with respect to the training part or the fundamentals. So that's the reason we give dedicated 2 months of time span covering all the aspects of digital that can be asked from not only digital like PD basics, fundamentals or TCL also that can be asked in the interview. Once this basics is done, then we will start with the projects. The projects will be block level as well as chip level. I think regarding the projects, what you are going to do, it has been already discussed by the trainer. These projects will go for 2 months. Now, in during this project, you will be doing hands-on over Synopsys as well as Cadence tools. The tools are installed on our own physical servers. You can log in into our servers 24/7 via VPN. So for students who are attending online or even offline, see now you are attending a session, students offline through projector, online students through the screen sharing they are seeing. Similarly, if you are accessing the tool, all online offline students will be having a small software installed in your system that is called Putty, through which you can directly log in into our remote server and you can access. We will give the user credentials through which you can log in and you can access the course. Coming to about the training schedule, our training schedule will go 6 days a week. During the basics, it will be Monday to Saturday, and in advanced training, it will be Monday to Sunday. During basics, Sunday will be off, and during advanced training, Friday will be off. So how we will do the training is digital design will go for 3 weeks, PD basics will go for 2 weeks, CMOS will go for 4 weeks. In that sequence, we will go. Now, whatever sessions we are doing, you will have access to the live session recordings. So we have our own portal that is inskill.in. I'm just trying to open that portal and to show about how you will be able to access the recording. It might take time, so till it open, I will take the discussion ahead. Once you are done with this uh, training, basics part of 2 months, you will be having a dedicated evaluation where are you thorough with the basics or not, or any revision is required. These all things will be evaluated. The evaluation score minimum is 8 out of 10. So if you are able to score 8 out of 10, we will move forward you to the advanced part. If you are not able to score, still we will move forward you to the advanced part. But after 10 days, again the evaluation will be there. So we will do 3 evaluations and we will leave up to you. We will give you that after 3 evaluations also that you are not able to score 8 out of 10. It will be difficult for you to understand. If again the candidates want to continue and he or she can do a parallel learning that he will revise and do, we will allow. But we are maintaining now. Suppose I am having 25 students in a batch, then I am making a criteria as performing candidates, average candidates, and not responding candidates. So if the candidate is not at all responding, we will remove him from the batch and we will see where what is lagging and we will conduct a separate sessions for them. If you are average candidate in the category of average candidate, then we will conduct additional supporting sessions. And if you are performing, it is well and good, you will continue the course. Now, what is the difference of 6 to 8 months? Candidates who are performing, for them, we will start the placements after 6 months immediately. But candidates who are average or who are not responding, they need some more time to complete the course. or they want to do revision sessions and all. In that, the duration maximum will extend till 8 months. After the basics and advanced, both the trainings are done. There will be a final evaluation. Suppose the training has been done in 7 months. So after final evaluation, we will create your CV. That CV will have both the projects, the skill sets, and everything. We have a predefined template. Through that template, we will share to the recruiters. And recruiters, very recently, the recruiters are getting back to us that these are the requirements. We need these trained candidates, even if it is 2025 pass out, 18 pass out, 20 pass out, 22 pass out. Those requirements we will put forward to you. And if you are interested to apply for that position, you can apply. These are the internal links through which you are applying. Your internal resume will come to us, and then that resume we will forward. Now, suppose you all get added into the job support group and you had applied, five of you had applied for that position. Since this will be a first interview that you are going to attend, there are chances of rejection also. So during the chances of rejection, what we do is, suppose I give you one requirement, you got rejected. Post that rejection, we will schedule a assessment session. That assessment session will be one-to-one, where a trainer will sit with you and he will ask what questions have been asked to you by the interviewer and what you replied. Then we will come to know what are the questions has gone wrong, or what are the answers you have by mistakenly given wrong, because of which you got rejected. This will be repeated after every rejection, so that if I tell you that in this interview, for the SCL interview, you have done these things wrong, so tomorrow, even if Capgemini interview comes, you will not repeat the same mistakes. And this will continue till every rejection you get. After every rejection, if I do the assessment session, the chances of rejection reduces, and hardly within 4 to 5 interview slots, you will be getting selected by the companies. That is first thing. Second is, since you are in job support group, the requirements are continuously coming, and the requirements are continuously coming. Suppose you get selected by Chipsol Technologies, they are offering 3.5 package. But after 2 months, I got a requirement from Samsung. So when I get the requirement from Samsung, if you wish to apply for Samsung also, we will allow you to apply. Because if you have selected the Chipsol Technologies and you have said yes, you have to give the genuine explanation to the company, and you can apply for other companies. From my end, there is no restrictions. I have people in the job support who were in 2023, they got a job, they worked in L&T, and then they switched to other companies also. And now also they are in the job support group. So they also keep posting if there is some internal requirement comes from their team. This is how our placement support will work. Any questions till now? Yes, offline students. Online, any questions? So my batch is starting from Wednesday. Since today is a demo session, few more students are interested to enroll. We are giving them the buffer time of tomorrow and day after tomorrow, and from Wednesday the actual classes will start. I will just go give you an overview of this portal. This is our e-learning portal, where once you enroll for the course, we will add you into. There will be two groups. One is a common group for all the participants, and one is the individual group. Individual group will include your trainer and the supporting staff. What is the need of supporting staff? That also I will tell you. Once the individual group is created, you will get the login credentials. That is the username and password of this portal. So if you go to the student login, you will be having the username and password that will be shared by my team. And then once you log into this portal, you will be able to see live session recordings. Suppose I have done this today session. Now also this session is getting recorded. So this recorded session will be available after a couple of hours. And this session will be there for two weeks. So now let's take an example. You are listening to me, but we are also accept that for offline students, even if you attend the full lecture completely active, still you will be understanding 70 to 80%. There is still 10 to 20% you might be missing. Similarly, in online, you are attending actively, but it might be internet fluctuation or some or other reason. You might not be able to give 100% of your attention. For that reason, the recording will be provided. Once we provide you the recording, you can go through it for 2 weeks. After 2 weeks, it will be automatically removed. See, for example, now, since we are doing a recording of each and every session, the complete course of physical design is available in the format of recordings. Here you are able to see the unit 1 PD, what we are covering. See, this is nothing but the live session recording. Now, the way I have gone, there was a tab for me like physical design. You will also have, you will be getting added into a batch that is B11. So for B11, you will see physical design live session B11 course. In that, once you log in, you will see every live session. This is the live session that we have done for this topic. Now, during this training, the trainers will be using some presentations. They will be using some notes, PDFs, and even they are maintaining a daily notes also. Those all will be accessible over here. See, you can see this CTS, STA routing. These are nothing but the notes that the trainer has maintained as a part of this training. Each and everything that they are covering as a part of this course, it is available in the portal itself. Now, the videos will be removed after 2 weeks, but these presentations, this assignments, notes will be available for complete 1 year. So for reference, you can go through them also. On top of that, see, now let's take an example. One candidate online as well as one candidate is offline. They are very well prepared. The course has ended, they will come to me and they say that, sir, I am very well prepared. Give me the job support. Will I have any clarity how much they are prepared? No. So what we do is, even, and on the other hand, when it comes to a trainer, even the trainer is 10 years experience. He is teaching a topic, for example, floor plan. The topic is for 6 hours. In that 6 hours, can he discuss all the interview questions? No, because he has to teach the concept, he has to do the practical also. For that reason, what we have done is, with respect to physical design, whatever interview questions are there, or even with respect to a particular topic like floor plan, placement, routing, these all questions we have clubbed together and we have added into this assignment. So you are supposed, now, if the candidate is coming and saying, sir, I am well prepared, and other candidate is coming and saying, sir, I have done all assignments. The person who has done all assignments, we are 100% sure that he can crack the interview because 90% of the questions he have already solved. Now, coming to the sessions, in the theory session, the way our trainer has explained you what you're going to do over the tool also. In the theory, each and every topic the trainer will explain you and you have to understand the concept, how it is done. Because whatever he has done, suppose he has explained 6 topics in 1 week, he will explain in 2 days. But the same topics you have to repeat in remaining 4 days of lab session. So 6 topics that he has explained, every day two topics will be taken by the mentor. Mentor will take a session for 3 hours in which initial 1 hour he will explain the topic and next remaining 2 hours he will ask you to do where you will do the hands-on. Now, coming to the assignment questions, we are not giving you the assignment and asking you to solve. In the lab sessions, the mentor will give you the solution of each and every question. When we are doing lab session, he will open the assignments and he will inform that today we will do this 5 questions. So 2 hours he will give you the time to solve, giving you the logics, everything. And another 1 hour he will himself solve. So that suppose you have solved using 10 steps, someone has solved using 7 steps. he will give you how it can be solved in a minimum number of steps. So every question should be solved here. But we are expecting, if you want to get into the industry as a physical design engineer, the syllabus that we are covering and assignment should be covered. If you are doing the assignment or you are attending regularly, your mock interviews or even evaluation will be easily covered, because our evaluations will be also inclined towards assignments. Is it clear? Any questions, online students? Last thing about this course is, suppose you are doing a training for even full week or full week or weekends, whatever training you are doing, you are attending in a batch and you are not able to ask your doubts in the group, then you have an option of schedule support session, where if you have we have done a session and you are not able to understand, or you are lagging behind and the course is going ahead, so you can ask for or request for a dedicated one-to-one support session. Our trainers and mentors, who are the subject matter experts, specifically mentors, they are available from 9 to 6, and even if required additional time also. Every day we do support session for our students, so we can arrange a one-to-one support session also for the students. Yeah. Any questions? So that's all from my end. Yeah. Here, any questions, anyone? Coming to the placements part, see, when it comes to physical design placements, the requirements in the companies are fluctuating. Sometimes in the quarter 2 or quarter 3 the openings are very high, in the quarter 4 the openings are less. Rather than talking about quarter, let me talk about month wise. Like, it might be in June to August the openings are very high, in September the openings are very less. So it the openings in physical design keeps fluctuating. What you can expect from us is, whenever the open companies are coming, we will be supporting you for all the openings. Now, if the openings are not there in the market because of the layoffs or the delays in the projects, then the openings will not be there. If I talk about recent placements, we have done the placements in Wipro, we have done in HCL, we have done now Siemens has came up us with the requirements. So there are two types of companies, that is product based as well as service based. Product based includes Samsung, Intel, Qualcomm, MediaTek, analog devices. Where the packages for freshers, it will be always above 6, irrespective of whatever is your college. If you are from IIT, NIT, they can offer around 11 to 14, depending upon your BTech or your MTech. If you go into service based like Wipro, HCL, and Capgemini, Mirafra, Chipsol Technologies, those kind of companies, you can expect a package of 3.5 to 6 lakhs. Now, what should be your expectations in physical design? In physical design, to be very clear and precise, product based companies are hiring on a lesser side. Why? Because for product-based companies, they will always prefer to go with, if they are hiring freshers, they will go for IITs and NITs. And if you are going, if they are hiring one, not in a bulk, one two candidates, then they will prefer to have experienced candidates. So, if you want to join as for physical design, you should have the expectations as per the industry requirements. Yeah. Any other questions? Yes, online students. Yeah, offline students. Any questions? Sure. So, since there are no questions, we will end the session here. And all of you might have filled the form for demo session registration, right? If not, also, there, I will share my contact number. This is my contact number. You can just WhatsApp me. This session recordings, I will share it to you. And before Wednesday, if you have any queries or anything, you can let us know. So you will receive an email today evening regarding your demo session link or recording link, followed by the course details also. Yeah. Any questions? Okay. So we will end the session over here. Thank you all for attending the session.
Okay, thank you.